Hello students, how are you? I hope all of you are good. In my last video, I completed the introduction part for the exercise 10.2, and in this video, I am going to start the introduction part for the exercise 10.3, which is a third exercise of the chapter vector algebra. And in this exercise, the problems is based on dot product. So it means we need to start the concept dot product or scalar product of two vectors. So to solve the problems in exercise 10.3, we need to know the concept of dot product or scalar product. So today's concept is scalar product or or dot product of two vectors. See here, what is this scalar product? Suppose this is a vector and this one is a b vector, and the dot product of these two vectors a vector and b vector is denoted by a vector dot b vector and is defined by magnitude of a vector into magnitude of b vector into cos theta, where theta is the angle between the two vectors a vector and b vector, where theta is angle between a vector and b vector, and the range of theta is, the value of theta is always greater than or equal to 0, less than or equal to pi. See here, dot product of two vectors a vector and b vector is denoted by a vector dot b vector, and it is defined by magnitude of a vector into magnitude of b vector into cos theta, where theta is the angle between a vector and b vector, and the range of theta is always greater than or equal to 0, less than or equal to pi. And observe one more thing here, a vector dot b vector is equals to magnitude of the a vector. So magnitude of the a vector means length of a vector. So length of the a vector means length is one of the constant number, and magnitude of b vector, magnitude of the b vector means length of b vector. So length of the b vector is also one of the constant number, and the value of cos theta is also one of the constant number. So therefore, product of three constant number is again one of the constant value. Therefore, dot product of two vectors is one of the constant number, and that constant is nothing but a scalar quantity. So that's why we call it as a scalar product of two vectors. So dot product of two vectors always we obtain one of the scalar value or one of the constant value. That's why we call it as scalar product of two vectors a vector and b vector. And in this concept we need to observe some concepts here. See here, the first concept is, that is a definition of the dot product, a vector dot b vector equals to magnitude of a vector into magnitude of b vector into cos theta. And second point is, we already known a vector dot b vector is one of the scalar quantity, and the third point is, see here, the third point is, if the value of theta is equal to 0, if the value of theta is equal to 0, magnitude of a vector into magnitude of b vector into cos 0, and the value of cos 0 is 1. Therefore, when theta is equal to 0, dot product of two vectors a vector and b vector is a vector dot b vector is equal to magnitude of a vector into magnitude of b vector into cos 0, the value of cos 0 is 1. So when theta is 0, a vector dot b vector equals to magnitude of a vector into magnitude of b vector. So in particular, see here, in particular, a vector dot a vector. So as you know that angle between the a vector and a vector makes an angle 0 degree with the a vector. Suppose this is one of the a vector. So angle between this a vector with itself is equal to 0 degree. Therefore, a vector dot a vector is equals to magnitude of a vector into magnitude of a vector. So magnitude of A vector into magnitude of A vector is equals to magnitude of the vector A square. I hope all of you are understanding. So it means that if you want to find the value of B vector dot B vector, it use what? Magnitude of B vector into magnitude of B vector, which is equals to magnitude of the vector B square. I hope all of you are understanding. And the fourth point is, now the fourth point is, see here, if the angle between the vectors A vector and B vector is equals to pi by 2 in the sense 90 degree. So then the dot product of A vector and B vector is A vector dot B vector is equals to magnitude of A vector into magnitude of B vector into cos 90, and the value of cos 90 is 0. So into cos 90, the value of cos 90 is 0, and 0 into anything is always a 0. So therefore, if the value of theta is 90 degree, then the value of dot product between two vectors A vector and B vector is equals to 0. So one more thing you need to observe here, if the dot product of two vectors is 0, then angle between that two vectors is equals to 90 degree. If angle between two vectors is equals to 90 degree, we call it that two vectors are perpendicular to each other. Therefore, if the value of dot product is 0, if the value of dot product is 0, it means that A vector is perpendicular to B vector. I hope all of you are understanding. If the dot product of any two vectors is 0, we conclude that two vectors are perpendicular to each other. I hope all of you are understanding. Now the fifth point, see here. The fifth point we need to observe here. So the definition of the dot product is A vector dot B vector equals to magnitude of A vector into magnitude of B vector into cos theta. So by this relation, the value of cos theta is equals to A vector dot B vector, A vector dot B vector divided by, shift these two quantities magnitude of A vector and magnitude of B vectors to left side. It becomes what? Divided by magnitude of A vector into magnitude of B vector. The formula for angle between two vectors A vector and B vector is cos theta is equals to A vector dot B vector divided by magnitude of A vector into magnitude of B vector. I hope all of you are understanding. Now the sixth point you need to observe here. Now the sixth point, see here. So I already discussed in my previous video. So along the x-axis we have one of the unit vector, that is I cap, and along the y-axis we have a unit vector j cap, and along the z-axis we have a unit vector k cap. And also we know that x-axis, y-axis and z-axis are mutually perpendicular to each other. If x, y and z-axis are mutually perpendicular to each other, then I cap, j cap and k cap are also mutually perpendicular to each other. It means the dot product of I with I or I with j. First I am going to consider I dot j. So see here, I is perpendicular to j. It means I already discussed, if any two vectors are perpendicular, then dot product is 0. Similarly, z dot k, so j is perpendicular to k. It means their dot product is also 0. Similarly, k cap dot I cap. So k is perpendicular to I. It means their dot product is also 0. Hence the value of I dot j, j dot k and k dot I is equals to 0. I hope all of you are understanding. Now see here, seventh point, or it may be considered as a sixth point. If you find out the value of I dot I, see here, I cap making an angle with I cap is equals to 0 degree. This x-axis makes an angle with x-axis is equal to 0 degree. It means that I cap makes an angle 0 degree with itself. It means from this concept, if the angle between any two vectors is equals to 0, then their dot product is equal to product of their magnitudes. So therefore, the value of I dot I is magnitude of I cap into magnitude of I cap. And we know that I cap is one of the unit vector whose magnitude is 1 and 1 into 1. So therefore, the value of I dot I is 1. Similarly, the value of j dot j, the angle made by the j cap with j cap is equals to 0 degree. So therefore, j dot j is equals to magnitude of j cap into magnitude of j cap, where magnitude of the j cap is 1 unit. Similarly, k dot k. So the angle made by the k cap with itself is also equal to 0 degree. Therefore, k cap dot k cap is equals to magnitude of k cap into magnitude of k cap. And we know that magnitude of the k cap is equals to 1. Therefore, the value of I dot I, j dot j and k dot k is always equals to 1. I hope all of you understanding. Next point is, that is the seventh point. If A vector is equals to 2i plus 3j plus k and B vector is equals to I minus 2j plus 4k, then the value of A vector dot B vector is equals to. So first thing, A vector is given, that is what, 2i plus 3j plus k dot B vector is I minus 2j plus 4k. So dot product of two vectors is obtained by multiplying the coefficient of I with I, j with j and k with k. Why? Because here if I multiply this 2i with the terms inside the bracket on second vector, that is 2i cap dot I cap, definitely 2 into I dot I, so the value of I dot I is 1, so 2 into 1. But if you multiply this 2i with remaining two terms, that is 2 into minus 2 is minus 4 and then I dot j cap, but the value of I dot j cap is 0, so 0 into anything is 0. Similarly, if you multiply this 2i with the 4k, 2 into 4 is 8, then I dot k cap, the value of I dot k cap is 0. So therefore 0 into anything is 0. So it means that to find the dot product of any two vectors, no need to multiply by each and every term of the first vector with the each and every term of the second vector. We just multiply the coefficient of I in the first vector with coefficient of I in the second vector and coefficient of j in first vector with coefficient of j in second vector. Similarly, coefficient of k in first vector with coefficient of k in second vector. Therefore, the value of A vector dot B vector is equals to A vector dot B vector is equals to. So here the coefficient of I is 2 and here the coefficient of I is 1. So 2 into 1 is 2. Similarly, 3 into minus 2 is minus 6. So 1 into 4 is 4. So therefore, the value of A vector dot B vector, 2 plus 4 is 6 minus 6. The value of A vector dot B vector is equals to 0. And one more thing, observe here, if the dot product of any two vectors is 0, then that two vectors are perpendicular. It means these two vectors, A vector and B vectors, are perpendicular to each other. I hope all of you understood the finding the value of dot product of any two vectors. Dot product of any two vectors is obtained by multiplying the coefficient of I in first vector with the coefficient of I in second vector, and similarly coefficient of j in first with coefficient of j in second, and similarly coefficient of k in first vector with the coefficient of k in second vector. And one more thing you observe here, the value of A vector dot B vector is 0, of course. So if you want to find the value of B vector dot A vector, then also answer is same. So 1 into 2 is 2, minus 2 into 3 is minus 6, then 4 into 1 is 4. It means that the eighth point is, we can say that A vector dot B vector is equals to B vector dot A vector. It means that dot product of the vectors is commutative. This is what? Commutative law. So dot product of two vectors is always commutative. So if we have A dot B anywhere, so I can replace it by B vector dot A vector because both the values are same. I hope all of you understood this concept of dot product of two vectors. So see here, I repeat once, dot product of any two vectors is denoted by A vector dot B vector, and its definition is magnitude of A vector into magnitude of B vector into cos theta. As you know that in this definition, the right side is a constant values. So if you multiply constant values, we get one of the constant value. So that constant is nothing but a scalar value. So therefore, dot product of any two vectors is always scalar quantity. And if the value of theta is 0 between two vectors, then the value of dot product of A vector and B vector is equals to magnitude of A vector into magnitude of B vector. So in particular, if you want to find out the dot product of a vector with itself, that is A vector dot A vector is equals to magnitude of vector A square, and B vector dot B vector is equals to magnitude of the vector B square. If the angle between two vectors is 90 degree, then the dot product of two vectors is equals to 0. It means that if dot product of any two vectors is 0, then that two vectors are perpendicular to each other. And the formula for cos theta, that is angle between two vectors, is obtained by using the formula A vector dot B vector divides magnitude of A vector into magnitude of B vector. So as you know that unit vectors along the coordinate axis, I cap is unit vector along x axis, j cap is unit vector along y axis, and k cap is unit vector along z axis. So therefore, I, j, k are the perpendicular to each other. It means I dot j, j dot k, and k dot I is equals to 0. And the angle made by the vector with itself is 0 degree. Therefore, I makes an angle 0 with I cap, j makes angle 0 with j cap, and k cap makes angle 0 with k cap. So therefore, the value of I dot I, j dot j, k dot k is equals to 1. And dot product of two vectors is obtained by multiplying the corresponding coefficients of I, j, and k in both the vectors. And dot product is commutative. And what is the last point? A vector dot B vector is equals to B vector dot A vector. I hope all of you understood the concept of scalar product of two vectors or dot product of two vectors. And in this introduction part, we need to know one more concept, that is, next concept is projection of A vector on B vector. A vector on B vector. So this is an important concept. From this concept, you are going to get 2 more questions in your annual examination. So here the concept is projection of A vector on B vector. So projection means shadow. It means shadow of A vector on the B vector. So we need to calculate the length of shadow of A vector on B vector. I hope all of you understanding. Projection of A vector on B vector is nothing but we need to calculate the length of shadow of A vector on the B vector. See here, how we calculate the projection of A vector on B vector. So let us suppose this is a A vector and this one is a B vector. This one is a B vector. So the projection of A vector on B vector is obtained by drawing a perpendicular line from the head of A vector to the B vector. So after draw the perpendicular line from the head of A vector to the B vector, the portion covered from the tail of the A vector to this perpendicular line. This portion is called as projection of A vector on the B vector. This portion, for example, P, Q, R. So PQ is called as projection of A vector on B vector. So this PQ portion is called as what? Projection of A vector on B vector. Now the question is, how do we calculate this length? How do we calculate this length? So for that, let us consider, let theta is the angle between the A vector and B vector. Let theta is the angle between A vector and B vector. PQR is a right angle triangle. It means in accordance with this measuring angle theta, QR is the opposite side and PQ is the adjacent side, and this longest side PR is hypotenuse side, and its length is equal to length of the A vector. So therefore, length of PR and PR is equal to magnitude of A vector. So length of PR is equal to magnitude of A vector. Now in this right angle triangle PQR, adjacent side is unknown, that is projection of A vector on B vector, but the hypotenuse length is known. When hypotenuse is known, adjacent is unknown, we use the definition of cos to identify the adjacent side, because the definition of cos theta is equal to adjacent divides hypotenuse. So therefore cos theta is equals to, here adjacent side is PQ, that is projection of A vector and B vector, PQ, divided by hypotenuse is PR. Hence cos theta is equals to PQ, the value of PQ is unknown as it is, divided by PR, length of PR is equals to magnitude of A vector. Therefore, PQ is equals to, by the cross multiplication, PQ is equals to magnitude of A vector into cos theta. I hope all of you understanding. So, length of PQ is equals to magnitude of A vector into cos theta, or in other words, we know that the definition of dot product of two vectors, we know that definition of dot product of two vectors, that is A vector dot B vector is equals to magnitude of A vector into magnitude of B vector into cos theta. So by this definition, A vector dot B vector divided by magnitude of B vector is equals to magnitude of A vector into cos theta. Magnitude of A vector into cos theta. So therefore, the value of magnitude of A vector into cos theta from the second equation substitute in the first equation. It means this first equation becomes, ನೋಡ್ರಿ ಏನಾಗುತ್ತೆ, PQ is equals to magnitude of A vector into cos theta is A vector dot B vector, A vector dot B vector divided by magnitude of B vector, divided by magnitude of B vector, where what is PQ? PQ is nothing but projection of A vector and B vector. Therefore, hence we find projection of A vector on B vector is equals to A vector dot B vector divided by magnitude of B vector, and which is the required formula to calculate the length of shadow of A vector on B vector. That is what? A vector dot B vector divided by magnitude of B vector. I hope all of you understood. So this is all about we required to solve the problems in exercise 10.1.